Welcome to ACP CIVIL HUB. In this video, we are going to study a complete general arrangement drawing package from a real pre-engineered building project. We will start with the anchor bolt plan and base plate details, then move through the main framing system, roof and wall sheeting layouts, and finally study important steel connection and trim details. The purpose of this video is not just to look at individual drawings, but to understand how different drawings in a PEB project are connected with each other. By the end of this video, you will have a much clearer understanding of how to read and coordinate a complete PEB General Arrangement Drawing package. So, let's begin with the anchor bolt plan. This drawing is the anchor bolt plan of the project. The anchor bolt plan defines the exact locations of the steel columns with reference to the structural grid lines. On the left side, we can see the existing building, while the new linter structure is arranged on the right side. The drawing shows the overall steel line dimensions, individual base spacing, column center lines, wall locations, and the identification marks for different anchor bolt details. These detail references, such as A, A1, A2, B, and C, tell us which specific base plate and bolt arrangement is required at each column location. This is why the anchor bolt plan must always be coordinated carefully with the individual anchor bolt details before construction begins. Here we are looking at anchor bolt detail A. This detail is mainly used for the sidewall column location shown by the corresponding detail A reference in the anchor bolt plan. The base plate size shown here is 350 mm by 250 mm. 4 M24 bolts are provided with 28 mm diameter holes. The bolt spacing is clearly dimensioned, and the surrounding wall position is also shown relative to the sidewall steel line. The base plate level for this detail is plus 2.875 meters from finished floor level. This detail allows the site and fabrication teams to correctly position the column and its supporting connection relative to the wall construction. This is anchor bolt detail A1. The main base plate arrangement remains similar, with a 350 by 250 mm plate and 4 M24 bolts with 28 mm diameter holes. However, the important difference is the location of the column relative to both the end wall steel line and the sidewall steel line. The drawing also shows the 300 mm brick wall and the 240 mm wall thickness. This makes detail A1 a corner condition, where coordination in two directions becomes important. The base plate level is again shown at plus 2.875 meters from finished floor level. Now we have anchor bolt detail A2. This is another special corner condition at grid line 27 and F1. The base plate is 350 by 250 millimeters and uses 4 M24 bolts with 28 millimeter holes. The drawing clearly shows the relationship between the base plate, end wall steel line, side wall steel line, and surrounding wall geometry. The offsets and dimensions must be followed accurately because even a small positioning error at a corner column can create alignment problems for the wall framing and cladding system. The base plate elevation for this detail is plus 2.875 meters from finished floor level. This is anchor bolt detail B. Here, the base plate size is 250 by 350 millimeters. The arrangement again uses 4 M24 bolts with 28 millimeter diameter holes. This detail is positioned relative to the end wall steel line and the 300 mm brick wall. The drawing also shows an offset of 175 mm from the reference grid line. Notice that the base plate level remains plus 2.875 meters from finished floor level. Whenever we read an anchor bolt plan, we should not assume that all columns use the same detail. Each detail reference must be checked individually. This is anchor bolt detail C. The base plate shown here is 250 by 350 millimeters, with 4 M24 bolts and 28 millimeter diameter holes. The bolt center spacing and edge distances are clearly dimensioned. An important difference in this detail is its elevation. Unlike the previous details located at plus 2.875 meters, Detail C has its base plate at plus 0.150 meters from finished floor level. This means that the column condition and supporting level are different. Always check both the plan location and the base plate elevation before setting out anchor bolts on site. Now we move from the foundation setting out information to the framing elevations. This drawing shows the end wall framing elevation at grid line A. The new linter structure is connected with the existing building on one side and supported by the new steel framing toward the outer side. The drawing identifies the rafter, roof purlins, goats, sag rods, eave gutter, downtake pipe, and other major framing components. The roof is provided with a slope of 1 in 10. The lower portion includes the existing RCC column and wall construction, while the steel framing continues above it. This elevation helps us understand the vertical arrangement of the structural frame before the wall sheeting is added. This is the corresponding end wall sheeting elevation at grid line A. By comparing this drawing with the previous framing elevation, we can understand the relationship between the structural members and the final external enclosure. The vertical sheeting is installed over the supporting wall framing, while the lower portion remains as the masonry wall construction. The roof sheeting follows the same 1 in 10 slope. Important external components such as the eave gutter, downtake pipe, and side cladding are also shown. The framing elevation tells us what supports the building envelope, while the sheeting elevation shows the final covered appearance of that same building face. This drawing shows the typical frame elevation between grid lines B to E. The total center-to-center distance of the steel column line is 21,085 millimeters. The individual base spacing is approximately 5.27 meters. The roof has a 1 in 10 slope and is supported by the main rafter, with roof purlins carrying the roof sheeting. A turbo ventilator is also positioned on the roof. At the outer edge, the drawing shows the eave gutter, downtake pipe, side goat, and side cladding. The clear height is shown as 5,000 millimeters near the outer side. This elevation gives us a clear view of the primary transverse framing system of the linter building. Now we are looking at the end wall framing elevation at grid line F1. This elevation includes an important feature, the rolling shutter opening, marked as RS. The opening is 4,075 millimeters wide and 5,000 millimeters high. A canopy is provided above this opening. The drawing also identifies the main rafter, roof purlins, goats, sag rods, roof drainage components, and the existing PEB and RCC columns. The base of the new steel columns is shown at plus 0.150 meters relative to finished floor level. This drawing is important for coordinating the structural framing around the large door opening. This is the sheeting elevation corresponding to the same end wall at grid line F1. The structural arrangement from the previous slide is now shown with the wall sheeting installed. The rolling shutter opening remains clear, while the surrounding upper wall areas are enclosed with cladding. The canopy above the opening is also visible. The lower portion consists of masonry construction, and the steel wall sheeting continues above it. Comparing framing and sheeting elevations together is one of the best ways to understand how secondary members support the final cladding system. This drawing shows the sidewall framing elevation at grid line 27. The steel columns are arranged along the building length, with horizontal girts connecting them. Rod bracing is provided in selected bays to stabilize the wall framing system. Sag rods are also indicated as part of the secondary framing arrangement. Below the steel framing, we can see the RCC columns and brick wall construction. The overall steel column spacing and building dimensions are shown along the bottom of the drawing. This elevation is particularly useful for understanding the location of wall bracing before the external cladding is installed. This is the sidewall sheeting elevation at grid line 27. Here, the structural framing from the previous slide is covered by the vertical wall sheeting. The lower portion remains as masonry construction between the RCC columns. Notice that components such as rod bracing are no longer directly visible in the finished elevation because they are located behind the cladding. This comparison demonstrates why both framing and sheeting drawings are required. The framing drawing is mainly used to understand the supporting structural system, while the sheeting drawing defines the final building envelope. Now we move to the roof framing plan. This plan shows the structural members supporting the roof sheeting. The roof purlins run across the framing system and provide continuous support to the roof sheets. Rod bracing is arranged in selected roof bays, and sag rods are also shown. The new lean-to structure is connected alongside the existing building. The roof slope is 1:10. And the framing layout follows the main grid and column arrangement. The locations of the braced bays are especially important because these members contribute to the stability of the roof framing system. This is the roof sheeting plan for the same structure. Unlike the framing plan, this drawing focuses on the external roof covering and related accessories. The roof sheeting follows the 1:10 slope toward the drainage side. Several turbo ventilators are shown across the roof area. The drawing also identifies 400 mm wide polycarbonate strip light sheets, which allow natural daylight to enter the building. The canopy area is also shown at the upper side of the plan. By comparing this drawing with the roof framing plan, we can understand exactly how the roof covering is supported by the structural system below. This drawing shows the eave detail of the building. At the roof edge, the roof sheeting is connected using fasteners, and the gutter strip directs rainwater into the eave gutter. From the gutter, water flows through the gutter outlet into the downtake pipe. The drawing also identifies the eave strut, girt, cladding, steel line, and main rafter. This is an important interface because several systems meet at one location: the roof sheeting, wall cladding, secondary steel framing, and rainwater drainage system. Proper detailing at the eave helps prevent water leakage and ensures that the roof and wall systems are properly connected. Now we move to the steel connection details. This is detail A, showing the connection between a column and a rafter. The rafter meets the top portion of the column through a connection plate. Bolts are used to assemble the members at the connection. The drawing also shows stiffening elements around the joint, which help transfer forces through the connection region. This type of detail is important because the primary structural members are fabricated separately and then assembled on site. The connection detail provides the information needed to correctly join the rafter and column as part of the main structural frame. This is detail B, showing a rafter-to-rafter connection. Two rafter segments are joined together using a connection plate and bolts. Additional stiffening plates are provided around the connection region. This type of bolted connection allows large structural members to be fabricated in manageable segments and assembled during erection. The exact plate dimensions, bolt quantity, bolt grade, and fabrication requirements must always be taken from the detailed fabrication drawings and project specifications. The general arrangement detail mainly helps us understand the connection concept and the relationship between the two structural members. This is the typical corner trim detail. At the building corner, the side wall goat and end wall goat meet at 90 degrees. Clips and M12 bolts are used for the secondary steel connections shown in the detail. The corner trim covers the junction between the wall sheeting on the two building faces. Self-drilling screws, or SDS fasteners, are provided at the specified spacing to secure the trim and sheeting arrangement. This detail is important for both appearance and weather protection. It provides a clean finish corner while helping to protect the junction between the two wall cladding surfaces from direct weather exposure. With this, we have completed the first 20 drawings of this general arrangement drawing package. In the next part, we will continue with the remaining connection and trim details and understand how these details complete the overall PEB construction system. Now, let us understand the typical gable trim detail provided at the gable end of the PEB structure. At the top, we can see the roof panel supported by the purlin. At the edge of the roof, the drawing shows the rake trim and rake angle arrangement. The rake trim provides a finish covering at the gable edge and helps protect the junction between the roof panel and end wall sheeting. The roof panel is fixed using number 14 by 25 self-drilling tapping screws, provided at 333 mm on center. The purlin is connected at the end wall framing location, and the drawing specifies two M12 by 40 mm MS bolts for the indicated connection. Below this, we can see the end wall rafter and end wall column forming part of the structural end wall framing. The end wall sheeting is installed along the external face of the building and meets the roof edge near the rake trim. This detail helps us understand how the roof panel, purlin, rake trim, rake angle, end wall sheeting, end wall rafter, and end wall column are arranged together at the gable end of a PEB building. Now, let us understand the goat connection detail shown in this drawing. The horizontal member shown here is the goat, which is part of the secondary framing system of the PEB structure. At the center, we can see the column connection arrangement. The drawing also shows two diagonal flange braces extending from the upper connection near the column toward the goat. These flange braces are specified as angle sections of L50 by 40 by 1.8 mm, typical. The drawing indicates M12 by 40 mm MS bolts at the brace connections. It also provides a separate call-out for 8 M12 by 40 mm MS bolts at the indicated goat connection locations. When reading this type of detail, always check the member identification, bolt size, bolt quantity, and exact connection location according to the approved project drawing. This detail explains the typical arrangement between the goat, column, flange braces, and bolted connections used in the secondary framing system. With this, we complete. Next, we have the material specifications and general notes for the project. The material schedule defines the required specifications for different components of the PEB structure. The roof sheet and wall cladding are specified as 0.50 mm TCT high-rib color-coated galvalume sheets of AZ 150 GSM. Flashing is also specified as 0.50 mm color-coated galvalume of AZ150 GSM. The schedule further provides material standards for built-up members, cold-formed members, X-bracing members and rods, high-strength bolts, machine bolts, and self-drilling self-tapping screws. On the right side, we can see the general notes. These notes provide project-wide requirements related to dimensions, structural modifications, painting, bolts, welding, and material properties. According to the drawing, dimensions are generally given in millimeters and levels in meters unless noted otherwise. Structural alterations, removal, or addition of structural members, construction materials, or load should not be carried out without prior consent as specified in the project notes. The notes also define requirements for high-strength bolts and machine bolts and emphasize that the correct type of bolt must be used wherever specified in the connection details. Welding requirements and material strength requirements for built-up sections, purlins, and goats are also provided in these notes. For any PEB project, these general notes and material specifications should be carefully reviewed before studying individual fabrication and erection details because they establish the basic technical requirements applicable to the drawing package. Now, this slide shows the issued for approval format included in the drawing package. The most important instruction mentioned here is that this drawing is issued only for approval and strictly shall not be used for construction under any circumstances. During the approval process, the reviewer can select one of three options: approved as drawn, approved with comments, or reapproval required. The format also provides space for reviewer information, signature, and date. Below this, the revision history section is used to record drawing revisions along with the revision number, date, and description of changes. The drawing control section includes information for design, drawn, checked, approved, and drawing scale. Finally, the title block contains important project information such as customer name, project name, location, drawing title, job number, and drawing number. Therefore, before using any engineering drawing at site, it is very important to check its latest revision and current approval or construction status. Now, let's quickly summarize what we have learned from this complete PEB General Arrangement Drawing package. We started with the foundation and anchor bolt plans, where the exact locations of columns, grid lines, dimensions, and anchor bolts are established. Then, we reviewed the primary structural framing, including the end wall frames, columns, rafters, and different frame elevations that define the main structural system of the building. After that, we explored the wall and roof systems, including wall framing, roof framing, sheeting layouts, purlins, girts, and other secondary structural members. We also studied important connection and trim details, such as column-to-rafter and rafter connections, girt connections, flange braces, and typical eave, corner, and gable trim details. Finally, we reviewed the material specifications, general notes, bolt and fastener requirements, and drawing approval information that must be carefully checked before fabrication and construction. The key takeaway is that a complete PEB drawing package connects every stage of the project, from anchor bolt setting and structural framing to roofing, cladding, connections, and final project documentation. Understanding how all these drawings work together is essential for accurate detailing, fabrication, erection, and successful execution of a PEB project. Thank you for watching this complete PEB General Arrangement Drawing explanation. In this video, we learned how to read and understand a complete real project drawing package, including the anchor bolt plan, frame elevations, wall framing and sheeting, roof framing and sheeting plans, important steel connection details, trim details, material specifications, general notes, and approval information. If you found this video helpful, please like, share, and comment below. Subscribe to ACP Civil Hub and press the bell icon so you never miss our upcoming practical engineering tutorials. In the next video, we will explore PEB structural 3D modeling and concept overview, where we will understand the basic modeling workflow, structural member setup, base levels, and how a PEB model is coordinated with engineering drawings. Keep learning, keep improving, and build it strong. See you in the next video.